पूजा तो हमारा क्लास शुरू होता है ये दार बंद करते दार बंद करना Rishita, can you hear me? Okay. Rohan, can you see the screen? Okay. Right. So, good afternoon to you. On Monday, I had some internet issue. Therefore, I could not conduct the class. So, the thing is that today, tomorrow, and day after, I'll only conducting the class. So, please log in on this particular link itself. Right? Do not, I mean, tomorrow, generally, on every Thursday, your respective faculties conduct your class. So you log in onto some different link. But unlike that, because I missed Monday's class, so I would like to compensate. And Thursday's class I will take. What you are seeing it on the screen is the list of labs, the list of labs which you are supposed to do during this semester. Now, out of that, write a program that use functions to perform the following single link list: creation, insertion, deletion, traversal. Traversal is nothing but display. This we have done. Write a program that use functions to perform the following operations on doubly linked list. Then circular linked list. Write a program that implements stack using arrays, right, and pointers. This we have already done. Write a program that implement queues, again using arrays and pointers. Pointers is nothing but linked list that we have done. So write a program that implement the following sorting method to sort a given list of integers in ascending order: double sort, selection sort, insertion sort. That we will be doing. Write a program that use both recursive and non-recursive function to perform linear search and binary search. So, right? Write a program to implement the tree traversal method and write a program to implement the graphs. Okay. So one we have done, then 4 and 5 we have done. So today we'll see the doubly linked list. Why I have delayed it? Because whatever you are doing so far, you the basic requirement was for the single linked list. That's the reason why I did not introduce the doubly linked list. But hereafter, the syllabus which we are going to handle, particularly the unit 3. In unit 3, it is basically the binary search tree. So for binary search tree, you require the knowledge of doubly linked list. Therefore, I thought that I'll start introducing you doubly linked list just before the unit 3. Okay. So today in today's class, I'm basically focusing on all creation, insertion, deletion, and traversal, right? And in the traversal, I would like to also traversal from beginning to end and traversal from end to beginning, because that will build your logic better. And considering that whenever your interview processes will start, maybe if the questions connected with doubly linked list will come, you will be able to do it. Secondly, the insertion also will complete insertion in the middle. Deletion also will do not just deletion, not just deletion at the beginning, but we'll see something more. Okay, so we close this. Yeah. So let's start from the introduction of double linked list, also called as doubly linked list. In the single linked list, also we had made a provision to store the data. That data could be an integer type of data, it could be a character type of data, or a combination of integer, characters, float, and so on and so forth. So same is applicable over here. And just to start with the simple thing, we are going to take only one element which can store the data, maybe one integer data, so that the basics are understood correctly. But that does not mean that the doubly linked list can store only one element as data. You can have the entire entity, right? And all the attributes of an entity in the form of data. That is, it can have a combination of character array, float, double, integer, so on and so forth, depending on what application you are handling. Depending on what application you are handling. So this info in general, the info which is stored in a doubly linked list is the user's data. Users in the sense the entity's data. That entity could be a book, that entity could be an employee, a student, or whatever your application is dictating. Next, the pointer next, as the word suggests, it is going to point to the node which is on the right hand side, node which is next in the linked list, or better if we can understand it, the node which is on the right hand side. So this is a pointer. Of course, it's going to be of the struct double or struct node type, this pointer or struct node type, which is going to store the address of the next node in the list. What new you are going to see over here is another pointer called as previous, right? Compared to your single linked list, you are going to see another pointer, which is the name of that pointer is we are naming it as previous, right? So this previous pointer is going to point, the previous pointer is going to point to the node which is on the left hand side of the current node. The node which is going to be on the left hand side of the current node. That's the reason why we are naming this pointer as previous. So this stores the base address of the previous node in the list. Now, from my past experience of teaching doubly linked list, this particular concept of previous and double, the concept of previous and double has to be understood very clearly. So yesterday I was having a small meeting with all your DS staff, data structure staff, and all the data structure staff were telling me that only some of the students are participating, and rest of the students, when you are interacting with the faculty, there's a time you are posing a lot of questions to them. So this is not understood, that is not understood. So other than this, generally those students who participate, that is Jolly, then Jai Shankar, Rohan, Rishita, Meghana, and Raghavendra. These are the names only which I see in the chat window. So my my suggestion to you, or my request to you, is that please participate. Whatever you are not understanding, have it clarified with me and during the class, during this class. Because what's going to happen, my explanation and their explanation will be different. They are not going to have this particular PPT in front of them. So something which you do not understand in my class, if you pose this question to them, probably the explanation may not be, firstly, the explanation will be different. Naturally, every faculty has got its own style of explaining. So it may not synchronize with what I'm explaining it to you. So very, I mean, in a very friendly manner, I'm open for any questions, any number of times you can put the question till the time you understand. Because if you do not understand this concept of doubly linked list, then binary search tree is impossible to say comprehend. Okay, so please clarify any amount of or any doubt. And there is, as far as I'm concerned, a doubt is a doubt. There is nothing like an intelligent doubt and a stupid doubt. Okay, so there are no gradations for a doubt. The doubt which comes to your mind is the most intelligent doubt as far as I am concerned. Okay, so please feel free and clarify your mind. So this is the previous, the pointer, which is an additional pointer, which we are going to place where in the structure. What basically I'm talking about is the structure which you are going to create for a node. That structure, hello, hello, अब बाद में बात करना. Sorry, the call. Okay, let's see the advantage. Firstly, the advantage of this, doubly linked list is that, as you are seeing, the additional pointer, right? The additional pointer. A doubly linked list is that we uh, the advantage of doubly linked list is that we don't need to keep track of the previous node for traversal, or no need of traversing the whole list for finding the previous node. Are you getting my point? In the single linked list, the pointer is always pointing to the node which is on the right hand side, right? But if we want to find the node which is the previous node, the alternative is that you have to parallelly run two pointers, like what you have seen in the code which we have used a number of times for different applications. So we parallelly have to run two pointers, one pointer going to the next node, and one pointer is a shadow pointer which is following it, right? So that is one way of smartly handling the previous node, right? That's one way of smartly handling the previous node. But that previous node is what? Is only the node which is just behind, which is not node which is just behind. But if we want to traverse few nodes behind, right, in the backward direction, there is no facility. There is no facility. So what we need to do? Suppose this is the node one, this is the node two, this is node three, this is node four, and suppose I want to go to node two. In the single link list I'm talking about, I have no other option but to go back to the first node and come to the next node, second node, right? But in the doubly linked list, since I have got a pointer pointing to the previous node, this node also has got a pointer pointing to the previous node. Then I can go this in this direction also. I can go in the forward direction, and I can go in the reverse direction. So the advantage of doubly linked list is that we don't need to keep track of the previous node for traversal, or no need of traversing whole list. Means just now, as I told you, if you assume that this is a single linked list, we have to go back to the first node and come to the second node. If at all from here I want to go to second node, right? So that is one big advantage in the doubling linked list. But the fact that there is an advantage doesn't mean that there are no disadvantage. Any disadvantage you can visualize. Now, I request all the students to participate. I don't want, generally, the moment I pose a question, these famous lists like Nandika, Rohan, Jolly, Jai Shankar, they answer, and you boys and girls have been answering most of the times very correctly. I appreciate you, but please give chance to others also. More memory is wasted since extra pointer. Very good, Durga Prakash. Ritvik, yes, some new name and additional memory for other pointer. Yes, Ritvik, you are right. So, so why students I'm requesting you or encouraging you to participate is because we are, just don't look as second semester or second year first semester. Now just start putting yourself as if you are in the third 3-2, and companies are coming to interview you. The companies are coming to interview you. So that is the time you have to be interactive. So get into the practice of conversing, or get into the practice of raising your hand and saying that, sir, I will take this answer, right? Because the companies want leaders. The companies do not want stragglers. That If the teacher asks me, then I'll answer, right? You will miss the bus. I'm telling you. You will miss the bus means what? Even if you know the answer and if you are feeling shy and if you do not practice raising your hand or getting up and answer, do not forget. Do not see. This is the opportunity for you to build your confidence, right? And I'm not going to say 10 times you are given a wrong answer, so marks reduced. No, right? Uh, Building your confidence is also my job, isn't it? So let me do my job. So you raise your hands. Good. Ritvik, you're right. What he has guessed is that more pointer need to be handled, right? And in case of manipulation also, extra pointer to be done with the addition of another pointer. Yeah, extra operation, yes. Extra operation also you have to do. So, in general, while there is an advantage, there is a disadvantage because for every node, you need to handle 2 pointers. For every node, you need to handle 2 pointers, right? So, in a diagrammatic manner, in the center, I require info, not necessarily that it should be only a single element. It can be a combination of elements. For example, if you are managing a student node, then it can have array of characters as his name, long int as his mobile number, and maybe float as his marks in a subject, right? So in general, I'm saying info. In general, I'm saying info. That does not mean that you should conclude that every doubly linked list can accommodate only one data as one of the elements. No, you can have a group of data. Basically, the node is representing an entity. Why I'm saying entity always is for with the view that in the next semester when you are going to handle object-oriented programming, for example, C++ or Java, there the class concept will come in. And a class, the very definition of the class is a blueprint of an entity. And what's an entity? Entity is a living or a non-living thing. Means what? Living in object-oriented programming, as the name suggests, any object which is around us. It could be living or it could be non-living. Student, living object, example. Book, non-living object. So they are called as entities. So class is a blueprint of an entity, right? So because this is a procedural language, this is a procedural programming language. In the procedural programming language, we have the nearest way of describing an entity is a structure, right? Is a structure. So that structure should help us in describing an entity. And what is that entity? A student. Student has attributes. What are the attributes of student? The attributes of the student are he has got roll number, he has got name, he has got address, right? He has got a section, he has got a branch, blah blah, right? And some of the properties. What are the properties like? He pays the fees, he gives attendance, so on and so forth. So that is a full description of a student, right? Let it be any student. Now, so that's the reason why again and again I'm saying I'm comparing this structure with an entity. Okay. Now, same thing, we'll convert that into our C code. Same thing, we'll convert that into C code. I'm calling this node. I'm calling this node as node itself. Struct node, right? Struct node type. Now, item type, info, node type, there's a pointer of struct node type, pointer next, and and node type, which is previous. And diagrammatically also, as you are seeing it, diagrammatically also you are seeing it. This is the previous, this is the next. And every node you will find something like that. There is something which is previous, something which is next. Previous, next. Isn't it? So the point to be noted over here is regarding the first node and the last node, right? What is the specifically distinct in the first and the last node? I'm not talking about this. This is the pointer pointing to the first node. Jai Shankar, please wait, let others participate. I want new names today. Yes, Vishnu Deep. Good. First node, previous is null. Very good, Vishnu. And Yash Atal, mm, the first node, previous. Yeah. Uh, Satvik, first, previous, null. Okay, good. Gautam, no previous in first. Okay. This is not the first node. This is not the first node. This is a pointer pointing to the first node, right? This is a special pointer which stores the base address of the first node. Okay, this is not the first node. The first node is this, and the last node is this. Last next is equal to null. Very good. Yes, Satvik. And they say the point, they point to a single node only. Okay, good. They point to a single node only. Fine, right. So I got your point, Meghna. Yeah, they point to a single node. That is, the first node is pointing only to the second node, whereas the last node is pointing only to the second last node. That's what Meghna is trying to say. Good. Yeah. So generally, all of you are correct. That's what, yeah, Meghna. Yeah, I'm with you. So that's what you are trying to, in other words, you are trying to say, and all of you are generally right. So this is a diagrammatic, right? Because see, we are not for a specific last node structure, right? We are not creating a specific first node structure or a last node. Means in that case, we would have created three structures. Third, common kind of a structure which acts as a first, last, and the middle node, right? Now here we are storing the null value. So the first node is the node whose previous is null. The last node is a node whose next is null, right? Very useful information, particularly for writing your algorithm. Very useful information because how to identify the first node? Because we are always keep the track of the first node. So also we need to keep a track of the last node, particularly in the doubly linked list, right? So let's go further. Now, we no longer need to use the previous location. We can get the previous predecessor of a node using its previous pointer, right? What I'm talking, I'm trying to compare the doubly linked list with the singly linked list. In the singly linked list, if I have to go to previous, either I do some smart act and maintain two pointers, and one is a shadow pointer, and one is the pointer running in the forward direction. But a shadow pointer cannot store the addresses of any node which is previous to the existing node, right? Any node which is previous to the existing node. For example, in the singly linked list, in the singly linked list, as this diagram shows, yeah, so damn thing is so sensitive. As the diagram shows, from suppose from uh, I can't traverse backwards. Can't traverse backwards. Uh, but I what I need to do is I need to go back to the first node, right, and come to David, right? So this is the that's what I'm trying to say. We no longer need to use previous location. Okay. In the doubly linked list, the insertion because of this in the doubly linked list, the insertion operation. What I'm trying to say, why I showed you this. Suppose I want to insert. Suppose I want to insert. Suppose I want to insert lay between Joshua and Miriam. Between Joshua and Miriam, I want to insert lay. So what I do, I create an isolated node, isn't it? I create an isolated node at the beginning to start with, right? And starting from the first node, I stop here, and then uh, insert the insert the next of Joshua is going to be the isolated node, and the next of Lay is going to be the next of Joshua, right? So that's some kind of jugglery we have to do, right? Some kind of jugglery we have to do. So in the suppose I want to insert what Lay in between Joshua and oh, Lay is already there. Some other name I should have given. Let me give it here itself. Say, say Ram. I want to insert somewhere between. Okay, I want to insert some Ram in between Joshua and Lay. Right. So what I need to do, I have to manage. I have to manage two things here, right? Like some of the students, some of you were telling me that the operations on doubly linked list are also more. Very smartly, I don't know the name who said this. Somebody, in addition to uh, difference between the singly linked list and doubly linked list, very smart answer I got that the operations also means what? Here I have to manage the previous pointer also. I have to manage the next pointer also. So this lay which is there is an isolated node. Now that isolated node, you have to presently when you create an isolated node, when you create an isolated node, this should be null and this is null, right? And if you need to insert it over here, then this null has to be replaced with the base address of Joshua. The previous of Lay is nothing but the base address of Joshua. And the next of Lay is going to be the base address of Miriam, right? And not only this, you have to go for a little further also. The next of Joshua is going to be the base address of isolated pointer, and the previous of Miriam is going to be the base address of Lay, right? So this is what you need to manage. This is what you need to manage, right? So that is why some student was saying that in the one of the disadvantage is the memory, that you require an extra pointer location in every node. And second point is you need to manage this, right? For deletion also, for insertion also, right? For deletion as well as insertion, you need to manage this. Students, are you with me? Anybody who is not understanding, please come to the chat window. Yes, Bogram. What I'm trying to say that when you are trying to insert lay in between Joshua and Miriam, suppose you want to insert lay between Joshua and Miriam, in the single linked list, we have to manage only one pointer, the pointer to the next. But in the doubly linked list, we have to manage 6 pointers. In the single linked list, we are managing only 3 pointers. In the doubly linked list, we may have to manage 6 pointers. How? The isolated node basically is going to have a previous and the next. So when we create an isolated node, as per the algorithm, the previous of an isolated node is null, the next of an isolated node is null, and the base address is of course there. Base address of this node is of course there. When I'm inserting it between Joshua and Miriam, like how you are seeing it on the top, the Joshua's next is going to the base address of Lay. Joshua's next is going to the base address of Lay. Whereas Lay's previous is going to be the base address of Joshua. God. Yeah, is going to be the base address of Joshua. Second, the Miriam's The Miriam's previous is going to be the base address of Lay, and Lay's next is going to be Miriam, right? If you do all this jugglery, then only this particular Lay becomes comes in between Joshua and Miriam, right? Like Rishita is trying to say, Joshua's next is going to be Lay. What is Lay? The base address of Lay, right? And further she says Miriam's previous is nothing but Lay again, right? Very correct. Now Lay's previous is Joshua, that is the base address of the previous node, and Lay's next is going to be Miriam, which is the base address of Miriam. Harihara, am I clear, Harihara? Okay. Any other student who would like to clarify? Okay. So so that's what again the four operations which are required as you are seeing it in the diagram. First, it was null. This is null. So this point number one, this null has to be replaced with the base address of Joshua, which is nothing but Joshua node, right? Two, this is null, right? This null is required to be replaced with the base address of Miriam, right? How how do you do that? What I can do? Lay's previous is equal to Miriam's previous, right? Lay's previous, which is null presently, is Miriam's previous. What is Miriam's previous? The base address of Joshua, right? Point this replacement, which is presently null. Lay's next is equal to Joshua's next. Joshua's next. What is Joshua's next? The base address of Miriam. So this, so this you are constructed. This you are constructed, right? But the isolated still it continues to be remain isolated. This has come here. This has come here. But the next of Joshua presently, which is pointing at Miriam, has to be broken. Presently, it is pointing here. This has to be broken, and it should start pointing to the base address of Lay. So that's what I put it in the dotted form, right? In the previous state, the Miriam was pointing to the base address of Joshua. That has to be broken, and Miriam's previous has to become Lay, right? So whether you previous slide, sir. Okay. Yeah. Bogaram, yeah. Anything? Previous to this also? Okay. This one you are talking? Yeah, finding one. See, here I am comparing the single linked list and the double linked list. Therefore, that particular statement, we no longer need to use previous location. Why? Because the previous location is already now what diagram which you are seeing is a single linked list diagram. Now in the single linked list diagram, for going to the previous, either smartly you need to tackle if it is immediately just previous, right? Or you have to go back and come from here and get the address and store it. Okay. But in the doubly linked list, because the structure itself is different, we have two pointers. Since we have two pointers, so the address of the previous node, that is the node which is on the left hand side, is already stored in every node. Every node has got the base address of the previous node and the base address of the next node. Yeah, Bagaram, am I clear or fine? Right. So these are 1, 2, 3, 4 operations which you need to do if you need to insert a node in between the existing nodes. Right. Now let us start the code. Let's start the code. Now in the code, the struct node, struct node, the previous pointer, right? Int n. So I'm building the information is just integer type and struct node next and struct node next. So this is the structure which is exactly same as a diagram, which is exactly same. This is the previous pointer, this is the int n, and this is the next node pointer. Clear? Now this is in the global area. All this what I'm say before main, everything is in the global area. So pointer h, temp1, temp2, and temp4. So all these are the temporary pointers which we are going to use when I start explaining you different say functions. Okay. Then the different functions which you are going to use, right? The declaration of the functions, function prototype or declaration of the function. Insert, instart. Instart means what? Insert a node at the starting point. In end, right? Insert a node at the end of the doubly linked list. In middle, mid. Insert a node in the middle of the linked list. Traverse beginning, right? Starting from the first node, go in the forward direction and display also. Traverse end, right? Go in the reverse direction, means starting from the last node, the tail node, go in the backward direction. We can go in the backward direction because we have a doubly linked list. In the doubly linked list, we have the address of the previous node. That is the node on the left hand side of the existing node. Then sort. You must have guessed, for sorting the linked list. Then search. Search a particular whether the particular number is there in our linked list or not. Update. I would like to change the value at a particular location with some other value, right? That is what I'm saying. Update. And delete. I would like to delete a node, right? So these are the prototypes. And coming to the main, I'm displaying the menu. Insert at beginning, insert at end, insert at position I, means you have to specify the position at which you would like to insert. Okay. Delete at any position. Display from beginning, display from end. That is case number 6. Case number 7 is searching an element, and case number 8 is sort the list. Case number 9, update an element, and of course case number 10 is your exit, right? So while one, that is your endless loop, and in the endless loop we have the switch case, right? So this is you are aware of that. So let me go a little faster. Now coming to the create node, right? Coming to the create node. Yeah. So whenever we have to create a node, what we do? Create a empty node or an isolated node. Okay. Int data, right? Int data is the some kind of a integer local variable. Now temp is equal to temp. We have already created this particular temp. What I'm talking about, this temp is already there in the global pointer. This is a pointer of your struct node type. This temp is a pointer of struct node type, right? So using the malloc, I want to create one. We need not have to say one here because by default it is one. But even if you write, there is no harm. 1 into size of struct node, right? Now this temp previous initializing to null, this temp next initializing it to null. Then I'm asking the user to enter a value, right? That enter value I'm taking using a scanf. I'm putting in the data, right? This data. You can avoid that one step. There is no requirement of this data. You can avoid that one step. You can straight away say in the scanf in the scanner straight away you can say temp of n over here, right? You can straight away say temp of n and you can avoid one particular variable. And count plus plus, I'm maintaining a counter that how many nodes are there in the doubly linked list. How many nodes are there in the doubly linked list? Clear about the create function? Whenever the request comes to add a node, the count plus plus initially set at 0. First time the request comes, so the count plus plus increases it to 1. Yeah, any clarification regarding the create? Looks like we have done it a number of times, so I don't visualize any issue. Right. Coming to the insert function. Now this insert function, as you are seeing it, I'm going to share this particular code with you. Don't worry. Here, struct node pointer h. This h is the header. That is the first node, head node. That is the h. I'm always pointing at the first node. So head, so h, right? So that's why that h, right? Now when you are trying to insert, a node, right? It's quite possible that there are no nodes, right? There are no nodes. We are starting afresh. We are just executed the code, we compiled, compilation successful, and we are inserting the very first node. So obviously h is null, right? So when h is equal to null, create, right? When h is null, create. So this I'm calling this create function. My goodness, this create function is going to give a call here, right? And it's going to ask the value at the node, and it's going to prepare the node with the previous null and the next null, right? Then it comes back over here because there are no nodes. H is equal to temp because H is the head node and there's the only node. So H, the pointer H and the temp both are pointing at the same base address. So also for the further operation, I'm also storing the h value in one more pointer called as h1, right? So the case of very first node to be added, is it clear? Is there any clarification? Anybody would like to seek any question or anything which is not understood? Please come to the chat window. If you understood, no problem. Yes, Obed. Obed, do you have any question? Obed, you would like to clarify something? Temp 1. We'll see it further, right? As sometimes we will be requiring. So in the future code, if it is going to be inserted somewhere in between, that time we may need. So therefore, we are keeping one more pointer where, so presently temp1, h and temp all are pointing to this very first node, right? As of now, it is not of use, but maybe in the future it will be useful. Right. Now, when will I come to else? When h is not null. When h is not null means what? Already there is a node. Okay. Already there is a node, and I am coming to the else part. But in the comment, you must have seen to insert at beginning. So if the isolated node if an isolated node is already existing, right? One node is already existing, right? So the H will be pointing to that node as you are seeing it over here. The temp is pointing to that node and temp1 is also pointing to that node. Are you getting my point? Now, again a request comes as you are seen in the menu, insert at beginning, right? So a call comes to this particular function. A call comes to this function because H value equal to null is false. So it comes to the else block. In the else block, I am calling create. That create is going to create an isolated node, right? It's going to create an isolated node. That isolated node, that isolated node. Now temp of next is equal to H. Are you getting my point? Because this is an isolated node whose next is going to be the node which is already there. Yes, no. Up to this point, any temp of next is equal to H. If it is no, then please have it clarified. If somebody is not understanding, see this particular if function has created a isolated node, right? Now once again the request has come to insert at beginning. So this node is already existing. So I go to create. I create the previous is null, the next is null. I'm storing some data. Yeah. So that the base address of this isolated node is temp. So temp of next is H because this H was initially the head, right? Now this was the head. Now this H of previous is equal to temp. What is H of previous? H of previous is this particular node whose previous was initially null. That null has to be replaced with temp. That null has to be replaced with temp and H is equal to temp because H has to come back. H has to come back. Am I clear? Am I not clear? I don't know. Anybody who is not understanding, please come to the chat. I should have actually explained this with the diagram. As I visualize students, I may not finish the complete code. So what I will do, because no matter how much I appeal to you that please clarify. I know that inertia is always there. 540 students are in the class. Most of the students will say, why should I ask? Yes, yes, Akashdeep. We are adding at the beginning, right? We come to the else block when there is already an existing linked list and H is pointing to the first node of that existing linked list, right? But the request has come to insert a node at the beginning, as I have put it in the comment. The request has come to insert a node at the beginning. So the existing linked list had a first node. That first node should get changed by the newly created node, right? That becomes the first node. Okay, so that is my else block. So what I'll do, though I'm appealing and still students are saying they have understood. Next class, probably I'll come back here. I will add a diagram and I'll explain it to you again. Right. So this is where insert a node. Now, coming to insert at end. I want to insert a node at the end. Now, how do I do it? If H is equal to null, right? It's quite possible because you are displaying a menu. You are displaying a menu. Ideally speaking, when you are asking insert at end, ideally speaking, anybody with a little bit of intelligence, he should not go for this particular option right at the beginning. Because when you know that I'm running the code for the first time, there are no nodes. So what is insert and end? Okay. Anyway, but we can't rule out the possibility. Suppose he gives this option, I want to insert at end when there are no nodes, right? You cannot rule out that possibility. You can't say that stupid, don't ask such kind of a request. Okay. So when h is equal to null, same thing, same procedure. Create, we call that create node. H is equal to temp1 is equal to h, right? So that particular case is handled. Clearly knowing that there are no nodes, somebody is trying to add a node at the end. So that particular has been handled. Else means what? There is a node, at least one node, or a full linked list is there, right? At least one node, or maybe a linked list is there. More than one nodes are already there. Then only we'll come to the else part. Reason being, h is storing, this h pointer is storing the base address of the first node. So it's not null, right? So this if condition fails, and because the if condition fails, it comes to the else block. So isolated node gets created, isolated nodes created, and please try to understand this, right? Obey. You are asking me why temp1. Now this temp1 of next is equal to temp. Temp1 of next is equal to temp. What is temp? That isolated node, right? Temp1, temp of previous is equal to temp1. Temp of previous is equal to temp1, and temp1 is equal to temp. Obed, you are asking me now this temp1. What is this temp1? This temp1 is nothing but, now make an assumption. Make an assumption. Obed, I'm talking to you. Make an assumption that the first option created was this. Yes. So one isolated node got created. One isolated node got created. So h, temp, and temp1 are all pointing at that isolated node. Now again, I make a request, insert at end, right? Insert at end. So when I go to create, that temp gets overwritten with the one more isolated node with previous as null and next as null, right? Now presently the temp1 is the only node which is over there, right? So temp1 of next is equal to newly created node, right? Temp of previous is equal to temp1, right? And temp1 is equal to temp. So where is temp1 now, Obed? And where is h? Obed, I'll be happy if Obed can answer. Rohan, I'll come to you. Sheikh Obed, are you there? Did you follow what I was trying to say, Obed? Or should I repeat? See, H is generally keeping a tag of the head node, and temp1 is keeping a tag of the tail node. That is the last node. Obed, are you able to listen to me? Sheikh Obed, are you? I don't know why he's not responding. Right. Okay. Whenever you. So what I will do, I'm also not very comfortable because if I add diagrams over here, the explanation will be better. So what I will do is I'll go to explanation of that particular function wherein I have inserted some diagrams. Okay, I'll not that I'm not going to explain you about this delete. No, I'll come back put the diagrams and explain it to you. For example, next one is the insert in the middle. Now, if I have to explain you insert in the middle, those students who are not able to follow only because I'm just giving that verbal, one diagram is worth 1,000 words, right? So, lazily, I have not added a diagram. I should have done that. So, what I'll do is maybe in the next class, I'll come back to both this insert at end, insert at beginning, and insert in middle. Insert in middle. Yes, Obed, you would like to say something? Yeah, Obed, what I was trying to tell as insert at end. The temp one, you said no, why temp one? So I said I'll explain why temp one when I handle some other function. So temp one is the pointer which is pointing to the last node, right? In this particular code, temp1 is the pointer which is keeping a tag of the last node. H is the pointer which is generally keeping a tag of the first node. Okay, that's what I was trying to explain because when I was explaining you the create node, that time the temp1 came and you posed the right question, what is the use of this temp1? Okay, Obed? Right. So it's not that I'm not going to explain you the delete function, nor that I'm going to skip your in. I'll put diagrams, and maybe in the next class I'll explain you much better. Okay. Now traversing from the beginning, right? I'm going to come to this because I'll be able to explain you with the diagrams, right? Now temp2 is equal to h. Traversing from the beginning means what? From the very first node toward the last node. Traversing from traverse end means from starting from the last node, you are returning back to the head node. Okay. So suppose the request has come to display the traversing from the beginning. Traversing from the beginning. Now temp2 is equal to h. What is h? The very first node. The very first node, that is the head node, is in H. So I'm manipulating one more pointer called as temp2, right? Now temp2 is equal to null. When can be temp2 equal to null? When H is null. And when H is null, what does it mean? That there are no nodes in the linked list. Isn't it? That there are no nodes in the linked list. So temp2 is equal to null or H equal to null. It means that the list is empty, right? List is empty. And return. Return means what? Go back to the calling function, which is nothing but your main function. The other situation, the other situation. Now there are three cases. The list is empty. You have not created a single node, but you ask, let me see what he will display when I ask him to traverse from beginning. So you will get list empty to display, right? There is no list to be displayed. So the list is empty. That's what I'm trying to say. Now the case two. What is the case two? The case two is that there is only one node. There is only one node, like here. When there is only one node, when there is only one node, the data is there in 10, right? The previous is null, the next is null, and the base address is 1,000. The base address is 1,000, right? So step one, temp2 is equal to h. What is h? As per the diagram, what is in h? Akashdeep. What is the value in h? 1,000. Yes. Yes, correct. Good. Thank you. Thank you. Some of the students are keeping a tag. Akashdeep is there or no? Yeah, Nandika, you're right. All right. I was looking for Akashdeep. I don't know why he is missing. So H is the very first node. Now we are taking the case. First, we handle the case when there are no nodes, right? So we straight away say, sorry, no display. Second, there is only one node. And as I told you, H is going to point to the first node, right? Call it the H is first node or call it the tail as temp1, both are same, both are correct, right? So if there is only one node, right, in the while condition, as you are seeing it over here, temp2 is equal to H. So temp2 is also 1000, H is 1000, right? So temp2 of next, what is temp2 of next? Temp2 is here and next is what? Null, right? Temp2's next is what? Null, right? So the while condition is not met. Temp2 of next not equal to null, but temp2 of next is null, right? So the while condition fails. When the while condition fails, we have a temp2 of n. What is going to be printed? Temp2 of n, 10. Correct. Temp2 of 9, 10 is going to get printed. Yes, Sahiti. Sahitya. Correct. Bhavana, correct. So we have handled two cases. Now, what is the third case? That there are more number of nodes. There are more number of nodes, more than one, right? More than one. That's the third case which we are going to consider. Let's see how the while loop will behave. Now, assume that there are more than one nodes, right? For example, I have taken temp2, right? Temp2 is equal to H. So temp2 is 1000, H is also 1000, right? But what is temp2 of next here? 2000, right? So the while condition, temp2 of next not equal to null, true. Temp2 of next not equal to null, true, right? So true means what? You enter the while loop. When you enter the while loop, what am I doing? I am printing temp2 of n. So I'll print 10. So I'll print temp. Now temp2 is equal to temp2 of next, right? So temp2 of next has gone to 2000. What is this? 2000, isn't it? So the temp2 is going to come here. Temp2 is equal to temp2 of next. So temp2 is over here and temp2 is storing the base address of this node, which is 2000, right? Please try to understand that its previous is storing the base address 1000. The next is going to store the base address of the next node, right? So what are we? Temp2 is equal to temp2 of next. So temp2 is presently here. Again, we come back to the while condition. Temp2 of next not equal to null. Make an assumption that because temp2 of next is 3000, so it's not null. So 3000 is here. 3000 is here. True, right? Because it is true, temp2 is presently standing here. Temp2 of n, so it's going to print 20. It's going to print 20. Again, temp2 is equal to temp2 of next. Temp2 has come here, right? Temp2 has come here. Now, when the temp2 has come here, the value in temp2 is 3000, right? This is the base address. Value of temp2 is 3000. So again, we are brought back to the while condition. When we are brought back to the while condition, again we are asking temp2 of next not equal to null. Now temp2 of next is null. So the while condition fails. But the while condition has failed, but we are supposed to print this 30, isn't it? If we do not add this particular statement, this last node's data will never get printed, right? That's the reason why when having come out of the while loop, we are having a statement called as temp2 of next. That's how from beginning 10, 20, 30, it will get printed. And with that, the traverse beginning function is over. You will go back to the main function. Anybody who has not understood traverse from beginning? Anybody who has not understood, please come to the chat window. If you understood, give a chance to those who would like to have a clarification. Please, students, it's a doubly linked list. Akashdeep, sir, if we take temp2 not equal to null in while condition, we need not to write printf statement out of the. We are taking temp2. Okay, temp2 not equal to null. Fine. Yes. Okay. Okay. Fine. Yes. I agree with you. Akashdeep. Yes. Yeah. Different logics. It's not that this is the logic and there is nothing else than this. Yes. That is also logic. You save one particular statement. Fine. Much efficient program. Yeah, Akashdeep, you're right. Okay. So as the chat window is looks silent, so it looks like again my appeal to you that do not go back. I mean, I don't mind you going back and asking, say, your faculty members to explain it again, but it will be better in the first instance itself you have it clarified. Therefore, my appeal to all the students is to please have it clarified. Now, traverse end, right? The logic is little different. Traverse end, the logic is different. There is a recursion. So all the students, please try to understand this recursive concept. There is a recursion. See, as you see the code, as you see the code, the recursion is happening. We are calling the same function again. Are you getting my point? The fourth statement here, traverse end, traverse end, by passing the int value. There is a recursion. So I would like to explain that with a diagram. Hope all of you will focus your mind. Hope all of you will focus your mind. And in case all those students who are generally silent, please wake up, try to understand. If you are not understood, now there are two things which you need to understand here. How the recursion happens. And during the recursion, what happens, right? I'm trying to make it as simple as possible. So, because generally whenever the recursion comes, you say, yeah, it's too boring. Let's not give it up, right? Anyhow, I'll mug it up and produce in the exam. So, why should I unnecessarily trouble my mind? Okay. But you need to understand recursion and recursion, what thing happened in recursion. If you put it in diagrammatic form, recursion is not that difficult, right? Anyway, so let's see the same thing we are trying to, uh, I'm trying to consider the same case. Mhm. Yeah, same thing. That is node 1, 10, node 2, 20, node 3, 30, right? But what I need to print now, because I am asking him to traverse from end. So 30, 20, 10 need to be printed, right? 30, 20 net is to be printed. Presently in the from the beginning 10, 20, 30. So we have to reverse it, right? So keep this same linked list is there and we have to go in the reverse order. Yeah. So traverse end. The logic is that temp2. Temp2 is equal to temp2 is equal to your h, right? Not equal to null. So temp2 is standing here. Temp2 is standing here, right? The first node. Temp2 is standing at the first node. Now, what is I is equal to temp2 of n? What's in I now? Yes, I is 10, right? I'm calling your attention, students, those who are not active in my class, please at least pay attention here. Now, because this recursion, you have to keep the tag of I. You have to keep the tag of I. Therefore, I'm drawing your attention again and again. Next step. Next step. Now temp2 is equal to temp2 of next. What is temp2 here? Temp2 of next. It has to go here. So temp2 has come, right? So statement 1 is over. Statement 2 is over. Is temp2 in head node. Yes, 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 Bogaram. I should have, temp2 to start with comes to the head node. So when you are coming from the main function, if you are asking to print in the reverse order, there h is equal to, temp2 is equal to h. Hariyara, temp2 is equal to h, and from main function we come here. So temp2 is presently pointing at h. That is the first node. Very correctly asked. Thank you, Bogaram. So this is what. So second step, we have come here. We have come here. What is the third statement? Recursion. What is the third statement? Recursion, right? And passing what? I. What is I? 10. Keep this at the back of your mind, because when I come back in the recursive order, I the track back, right? When I track back, this is going to be of immense use as far as understanding is concerned. In the forward direction, what is it's calling the traverse end. The traverse end, if you see the code, it has got integer as a parameter, right? So I'm passing this I. I'm passing I. So the call has come. So what the value of I here? 10. What about temp2? Temp2 has come here. Not equal to null. True. Right? Now here, now same function has called. Presently I has gone. Right? And now I is equal to temp2 of n. But temp2 has come here. So what's in I now? Correct. In I have 20. In I have 20. Now again, one more temp, next statement. Temp2 is equal to, these are not different functions. This is the same function. Because of the recursion, to make you understand the recursion, I'm trying to repeat it again and again. They are not different functions. They are the same functions. For the sake of simplicity and understanding, I'm repeating it again. Right. So now this statement is over. In this particular recursive call, the value of I is equal to 20. Right. Now temp2 is equal to temp2 of next. So temp2 has come here. Temp2 has come here. Right. Now I am calling recursively one more time and passing I. What is I? 20. Right. So this I which is passed is 20. Okay. So the third time it's coming. Third time it's coming. Temp2 not equal to null, because temp2 is storing the base address of 3000, not null. True. Now I value, how much? 30. Right. I value is 30. Right. Temp2 is equal to temp2 of next. How much temp2? What's in temp2 now? Null. Yes. Good morning. Good afternoon. Aman Singh Jolly. First time I'm seeing you. No, no, not sorry. Not sorry. You are a good student. I only appeal to all these guys whose names are generally seen, right? To be silent for today's class so that others get opportunity to clarify their mind, right? So as all of you, Meghna, Jolly, Sheikh Abed, and others are saying that now temp2 of next is null. Now temp2 of next is null. But there is a recursive call, right? Recursive call. Now this recursive call is going to do what? Is going to call the same function again. I'm not repeating it here. Temp2 not equal to null. Temp2 not equal to null. False. False means what? True. Up to this understanding is fine. False. जाएगा कहाँ? False means where will it go? The control. Now the track back. Yes. Yes, Sai Satvik. Which print function corresponding to, now there are three traverse end. Which print function it is going to? Base case is achieved. Yes. Base case is achieved. Okay. Yeah. Yes. Ritika, Ritik Jain, 30. Satwik, 30. Yes, very good. Padma Surya, Teja, yes, 30. Durga Prakash, I don't know what you are going. 30. Right. See, this function, when this particular code was third time recursively called, right? This is the time it has failed. So it goes to the next step. What is the next step? I. What is the value of I? 30. Right? Now this is the last statement. This is the last statement of the traverse end. Who called this function? Who called this function? This 30, where I was 30, who called that? Who is the calling function? When I value is when I is 20, isn't it? When I is 20. So no confusion. When since this was the last statement, who called this? This function called. But where? This state up to here it was already executed. So it's going to come to the printf function of this stage. And what is I here? 20. So and who called this? This function called. What is the value of I? 10. Right? And it goes back to the main function. That's how we are going to print it in the reverse direction. That's how we are going to print it in the reverse direction. Anybody who has not understood this recursion, students. Now you may say, sir, temp1 was storing the tail, so why can't we use temp1? Correct. You can use temp1 because temp1 was like H is pointing to the first node. Because we have previous, we can use temp1 and go previous till temp1 of next not equal to null. Meghana, anything? Okay, last part explain again. Yes, I'll explain. Meghana, you want to, can't we use temp2 of previous? Temp2 of previous. Uh, temp2 is an isolated pointer, Vishnu, but temp1 was keeping a tab of your last node, and H is keeping a tag of your first node. So, since always temp1 will be going to the last node, right? I can say while temp1 of next not equal to null and go temp1 is equal to temp1 of previous, and that way also I can come back. Now you are telling me why temp2 of previous equal to not equal to null. Why can't we use that? Temp2 is not being used so far. It's just one more additional pointer which I am using it in this function to take the value. Yeah. Temp1 of previous is, I was about to ask, sir. You already clarified. Yeah. Yes, Meghna. Yes. That logic also will work. So no need of recursion in that case. So if you want to, and between the recursion and what Meghana is saying, which is better? Is recursion better or use that temp1 is better? Rohan says no, and means recursion is not, recursion is smaller, sir, to write. Yes, I agree. But Rohan is saying we should avoid recursion. Rohan is saying temp1 is better. Why? Temp1 easy to understand. Yes, Vishnu. Obed saying recursion is better. See, what is the advantage of recursion? The code is less, right? I agree. But what is the disadvantage? I will go with Rohan. Reason being, every time the function, yeah, space complexity, absolutely right. Every time the function is recursively called, one stack is created for that particular stage, right? Therefore, Rohan and Jai Shankar is saying it will take more space. More space means more time, more times means what? Less efficient. More time means less efficient. Therefore, you can also try using temp1, which is always keeping the tag of the last node. And using the previous, you can come back to the temp1 of previous not equal to null. That logic you can use and come back, because luckily we are in double linked list, right? Previous is there. Okay, so students, I'll continue in the next class with the same code. I'll continue in the next class with the same code. That is tomorrow. So once again, I'm telling you, tomorrow, please log in to the same URL. Do not go back to your faculties. Your faculties are not taking a class because unfortunately my network was not working at my residence, so I could not conduct yesterday Monday's class. So I requested all your faculties that let me take one more day. So please tomorrow log in on the same URL. Now you have got one quiz. Please take the quiz. Thank you. See you tomorrow at 1.
Yeah, good afternoon, everyone. Is my audio audible to everyone? Okay. Thank you, Nandika. Yeah, actually, yesterday we kept a quiz on linear probing, right? So maximum got full out of full. And additionally, I gave you one question, right? As a program since underscore dump, right? So 440 and the 440, 170 got full out of full. So 170 means passes the test cases. The 440, 170 is cleared. And 16 students are trying to solve but is not up to mark, and 29 students are being 16 are up to mark and 29 also submitted, but they do not got grade. Okay, so 170 is a very good number, but I don't know about the remaining students too, because yesterday the 5, I think lot of students are logging. I think as a 530 520 I think, but in that one 170 has been logged in 170 has got full star. Please everyone has to try, because this question may be repeated in your further unit exam also, so please make sure that one. Okay, today also I'm going to keep an one quiz. It's a basic quiz of double linked list, what you right now, what you understand. So that is a quiz I'm going to keep you. It's an 15 questions are there. So 15 questions is simple questions. Okay, please go through it. And I want to discuss the previous quiz also. I want to wrap up very fastly. Okay. Okay, guys. Yesterday we kept a linear probing question, right? The linear probing quiz. Okay. So first question is, hashing can be used in an online spelling checker. Yes, it's true. This is advantage. We can call an what is it called, when you're going to checking a spelling checker, hashing is going to check it. As a sir given an example of when you're going to submit a password in the Gmail, whatever typing, suppose if you type an eight digit, but when you're when clicking on submit, it will get a lengthy password. Why? Because it's going to perform an hashing. So here spelling checker is also done using a hashing table. Next question is linear probing. The cost of an unsuccessful search can be used to compute average cost of successful search. Yes, true or false means true. In linear probing, unsuccessful search can be used to compute the average cost. Even if there is a what we call the answer, you can understand the meaning of a cost or cost regarding. So when you come into an advanced classes like there is a called software engineering, there you're going to understanding what is the cost, average cost. So that time you can understand. But here it's a given clearly question that one. If unsuccessful search also you're going to pay. It requires some cost. Okay. And next question, third question I gave you, right? 49. In which of the hash table, where we going to 49 is going to insert. Here you can check it here. Okay. Here you can check 49. So 49 mod, what you can call 49 mod 10 is what is the value? 9, right? 49 mod 10 is, answer is 9. So already here in the here linear here in the hash table in the 9 already 8 9 is fitted. So in the linear programming I gave you given the question. In the linear programming the next space is going to occupy. Where is the next space is there? Again there is 10 is not there. So it will go for first position and you are going to insert here. So which one answer is 0? Right? So and the next question I gave you on what is the hash function using in a linear programming? Which one is going to use? How the hash function is generated? Key plus f of function. Key plus f of a mod of table size. In the previous question also given, right? Some there are 2000 records are there, 25 sizes there. So how to calculate that one? 2000 divided by 25, 8 is the answer, right? Here how to calculate the hash linear programming? Key, compressor key plus function mod table size. Okay. Fourth question option is C. And the fifth one is which of the following is a not collision resolution strategy for open addressing? Which one? Rehashing. There is a not a collision. What is the meaning of hashing? Hashing, whenever you are applying some data to hashing, there is a, you will get a, some different call different data. Okay, so when you can check in online, suppose if you give some high to perform a hash, then you will get a very big length code, the 256 bit code. So here we ask the question that what is a not a collision? Not collision is rehashing. Rehashing, again if you perform hashing also you will get a original text. Okay, which are the following problem occurs during a linear probing? Which one? Main thing is primary collision. In linear probing, all in data in the previous example, third question we see, just now we saw that one. Already the ninth bucket already filled. So if you want to insert some one value, there is called a collision is occur. So mainly in the linear probing, problem is linear. What is called? There is a collision. Primary is a collision. So already you know this one. This is not a normal hash. I'm going to repeat it this third time. This question. It is these are the same hash is 9. Here are the same hash 1. So which one 1 and 2 are correct? Okay. B is option B is correct. Here all the elements are the same value means here whatever I given you input here doesn't have the same hash values. The different values, right? That's why this is wrong and this one also wrong. So answer A and B are the correct. 1 and 2 are correct, and so option B is the right one. This one also. If several elements are computing for the same bucket in hash table, what is called? What we call collision. So what is the technique to avoid the collision? Normally we go for an hash function appear random hash function. We go for the chaining method and we go for the uniform uniform hashing. These are three or to avoid the collisions in a hashing. And last one is how to calculate load factor. Load factor is nothing but a chain length. Okay, this is a chain length. These are the 10 questions I gave you. In that one, a lot of students got full out of full only, but I don't know about a program because a lot of students are not doing the program. But up to mark, the please please everyone has to do the program also. And today I'm not going to give any program, but I'm going to connect only quiz on double linked list. Anyone have a doubts regarding the quiz, please raise your hands. And one more thing guys, for unit test we are going to give a one PDF file. It consisting of 200 MCQs, whatever daily classes whatever we conducted, quiz totally we are converting into PDF one which we are providing to everyone. So you have to collect it from your respective faculty. They will provide you that PDF, and in that one the MCQs are coming from a unit exam. Okay. If any person have a doubts regarding quiz, please raise the hand here. In whatever just now explained the quiz, There are totally 448 attended. In that one, 361 got means I can call 70%. 70% got full out of full. Okay, and I think in that this is normal G in the sense there will be less than 100. 66 got. Actually, we were
Shankar, sorry,
sir.
Shankar sir, uh,
Yes, sir.
announcement for the students. Students, for the first internal, you are going to have two programs, not internal, first mid. You are going to have two programs out of the 17 programs which we are going to cover till first mid, and there are going to be 30 MCQs. So these 17 questions we will be sharing with you. The code for these 17 questions will be sharing with you, and the answer for 200 the MCQs will be sharing with you. Okay, so all of you are expected. Every student is expected to do two programs, and 30 MCQs. And it's going to be randomly out of the 17. Any two programs may come to for you to execute. So you have to execute on the tessellator, and there is no choice. We are not going to entertain. Sir, I was absent for that class. My network was not working. This that. Unfortunate. You have to do only those two. If you can't do, you will get zero. If you do one, you will get 50%. Thank you, Shankar.
Yes, sir. So anyhow, today we are going to share that sheet 200 MCQs. Till now, whatever I given in an exam, a normal quiz, in that questions only I am going to give. Today, definitely I am going to share with your faculty. Please collect from your faculty. Any doubts in that today's quiz? And quiz is also started at very late, right? It's exact 2:23, right? I gave you for 15 minutes of time. Already 10 minutes crossed. Exactly at 2:40, I'm going to stop the quiz. 2:40, I'm going to close the quiz. That's it to a class. Okay. Thank you, guys.